Assalamualaikum, I'm Ashfaqur Rahman Ifti from Team Red Hill. In this video, I'm going to discuss about the thorough process of RAM construction and its operation in SAP1. First of all, let's go through the definition of RAM. According to Wikipedia, RAM or random access memory is a form of electronic computer memory that can be read and changed in any order, typically used to store working data and machine code. It has two operations, read and write. In read operation, the data is stored previously and RAM reads it, and in write operation the input data is stored in desired address. Now I will discuss about the construction of RAM. So here's a example of single bit binary cell. This is the basic block of RAM. A real life RAM can consist of thousands or more of these binary cells. Here we can see we have 4 pins: select, input, output, read and write. I'm not going to dive deeper here. Let's move on to block diagram of binary cell. So this is the block diagram of binary cell. Input pin takes the input from user, and output pin sends output to bus. Select pin selects the address to store and read data, and read or write pin decide whether to read or write the data in allocated memory address. So this is the operation of these 4 RAMs. Now we will discuss about the IC we used in simulation. We used 7489 IC. It is a 16x4 memory cell. It can store 4-bit data in 16 different addresses. Here the input pins are D1, D2, D3, D4. These are the input pins, and the address pins are A0, A1, A2. Output pins are Q1, Q2, Q3, Q4. We can see that all output pins are inverted, or they are active low. We also have another 2 pins, write enabled and memory enabled. Both are active low. And like every IC, we have ground and VCC for biasing. And this is the internal circuit of 7489 IC. It is taken from the datasheet of IC. So we can see that address input A1, A2, A3 and A0 are going through a decoder to the binary cells, and select pin enabling a specific row, whereas disabling the other rows. Read and write pin defining the operation of RAM. D1, D2, D3 and Q1, Q2, Q3, Q1, Q2, Q3, Q4. These are input and output lines of the RAM. This is a simulation, and here we can see that we use 27489 IC, and we grounded A3 of each A3, or the last address input of each IC, to make the address 8 address line. Also we grounded 2 input and output lines to make 6 input and output lines. This is how we constructed a 8 into 6 bit RAM. Here we can see that write enabled is active low. Write enabled is active low, we can say that if the input is 0, write will be enabled, and if the input is 1, read will be enabled. We have another pin we discussed before, which is memory enabled, which we grounded. It is active low, so we enabled it, so we grounded it, and as we don't require to turn off the RAM in the simulation, so we kept it active for throughout the simulation. The main downside of this IC is that the outputs are active low, so we had to use 6 NOT gates. Here we can see the outputs are going to bus, We further added one more IC, which we'll be discussing soon. Now the buffer 7424345 IC, 74245 IC, we can see this is the IC we used in our RAM. So it is called a buffer IC. It has 8 input and 8 output. Using this IC we can achieve unidirectional flow of data. We can say that chip enabled or CE is active low, and which is denoted in our simulation as RO or RAM output. When enabled, buffer acts like positively biased out or passes the data. Otherwise it does not pass the data. This property is used in order to prevent the data to come to RAM from the bus. RO is controlled by a control sequencer, which will be discussed in later video. Now we will see the actual simulation of our RAM circuit and the operation. So this is our circuit in simulation. Previously we saw that we used 27489 IC and 1742445 IC and some NOT gates. So these are our input data, these are our address data, this is read write, and this is RO, which is coming from control sequencer, and these are our output data. So now what RAM does? RAM stores data in preferred memory address. We know that 0 is read and 1 is write. 0 is write and 1 is read. So we want to do write operation. We want to store at address 000 000 001. Now we will